Geometric sequences. Geometric sequence is a sequence in which pairs of successive terms have a common ratio or quotient. So we can test for geometric ratio by dividing each term by the number before it. So 3 divided by 1, 9 divided by 3, and 27 divided by 9 all give us an answer of 3, which will be the common ratio. So the recursive formula means we take to find the next term, or the next value, take the previous value, and multiply it by the common ratio. In the explicit formula, to find the next value, you take the first value and multiply it by the common ratio raised to the n minus 1, n being the term number. So if we're going to write the explicit and recursive functions, we need to know what the starting term is, what the common ratio is, and whether or not we're going to write the recursive or explicit. So for the recursive, the next term is equal to the previous term times the common ratio, in this case, times 3. For this one, the common ratio, since we're dividing by 2 each time, we can think of multiplying by 1/2. So the recursive formula here is the previous term times 1/2. For the explicit form, we need to name the first term, and we're going to multiply it by the ratio raised to the n minus 1. So we're going to name the first value, multiply it by the ratio raised to the n minus 1. So we want to know if the sequences are geometric, and then we'll identify the common ratio, and then we'll work on finding the 20th term. If we're looking for a 20th term, we probably want to use the explicit formula because we can jump to the 20th term without needing to know the 19th. So from the first to the second term, we're going to be multiplying by 1/3. That works from the second to the third. But from the third to the fourth, if I multiplied 1/3 by 1/3 again, I should have 2 over 27. Since I don't, and I don't have a common ratio here either, or one that's common with the ones that came before, this one is not geometric. In the second example, we've multiplied by 2, by 2, by 2, by 2. So the common ratio is 2. The first term is 3. So to find the 20th term, we're going to take the first term, multiply by the common ratio, raised to the n minus 1, which, since n is 20, the n minus 1 is 19. So we take 2 to the 19th, multiply that by 3, and we get an answer of 1,572,864. For the next example, we need to figure out if it's geometric, and then we'll look for the common ratio. So I want to divide these and see if we get the same quotient every time. So let's take 10 to the negative first divided by 10 to the third, negative third. That's really the same as taking 10 to the negative first minus negative 3. So the ratio between them is 10 to the second. If I do that again, and I subtract the exponents, I'm going to get 10 to the second again, so that's my common ratio. So the 20th term will be equal to the first term times the common ratio raised to, again, the 19th power. We're going to get a really large answer, but we can easily write it out in its exponent form. So if we raise 10 to the second to the 19th, that's to the 38th. Then we're going to add the exponents here. So 38 plus negative 3 gives us 10 to the 35th. If you want to know more about solving these things on the calculator, I'll be posting this link. You can look over that and see how to do some of these sequences things on a graphing calculator. I would like you to try on your own this type of problem. This is what you're going to answer on the Google form. If you're given the second and fifth terms of a geometric sequence, and they're 8 and 64 respectively, find the first term and give a recursive rule for the nth term.